You may have heard that apple seeds contain cyanide. So do cassava roots, bitter almonds, peach pits, cherries, and even sorghum. So here's the obvious question. If these foods contain cyanide, why aren't people dropping dead after eating them? I mean, we all can swear that we have eaten these foods before. Not once, not twice, but severally. Yet we are still alive and still as fit as a fiddle. Well, the answer is a fascinating combination of chemistry, biology, and food processing. Let's break it down. First, it's important to note that most of these foods do not contain free cyanide floating around inside them. Instead, they contain compounds called cyanogenic glycosides. These are larger molecules that can release hydrogen cyanide, but only under certain conditions like low pH or through enzyme action. Some common examples of cyanogenic glycosides include amygdalin found in apple seeds, apricot kernels, and bitter almonds, linamarin, which is found in cassava, and durin, found in sorghum. You can think of these molecules as a self for cyanide, literally a chemical self, because the cyanide is locked up in these molecules and can only be released under certain conditions. Naturally, plants use cyanogenic glycosides to defend themselves against herbivores. The cyanide releasing molecule, which is the cyanogenic glycoside, and the activating enzyme are stored in separate compartments inside the cells of the plant. When the plant tissue is damaged, for example, when someone chews the seed, the enzyme and the glycoside finally meet. Only then does the reaction that releases hydrogen cyanide occur. So if these two don't come in contact, there's no reaction. The hydrogen cyanide will remain inside the chemical safe, which is the cyanogenic glycoside. One major reason people don't get poisoned is surprisingly simple. Most of the time, we swallow the seeds as a whole. Seeds like apple seeds and cherry pits have very tough outer coatings. If the seed isn't thoroughly crushed or chewed, digestive enzymes have limited access to the cytogenic compounds inside. As a result, most of it passes through the digestive system without releasing a significant amount of hydrogen cyanide. In other words, the chemical step never opens, so the cyanide never becomes available because it's not released. Even when some cyanide is released, the amount from normal food consumption is typically very low. This is where one of the most important principles in toxicology comes in. The dose makes the poison. Small exposures can often be handled by the body's natural detox system. Problems arise only when the amount released exceeds what the body can safely process. This is why occasional accidental ingestion of a few apple seeds does not normally cause harm in healthy individuals. Humans actually have a built-in defense against small amounts of cyanide. Inside the liver and mitochondria is an enzyme called Rodnase. This enzyme converts cyanide into a much less toxic compound called thiocyanide by transferring a sulfur atom. Thiocyanate is far less harmful and can be excreted in urine. However, it is very important to note that this detox pathway has limited capacity. It works well for small exposures but can be overwhelmed by large amounts. So there's a limit to how much it can handle. Food processing makes a huge difference. This is especially important for foods like cassava and sorghum. Traditional food preparation methods like soaking, fermenting, drying, grating, and cooking dramatically reduce cyanogenic glycosides. For example, proper cassava processing allows enzymes to break down the cyanogenic compounds and allows hydrogen cyanide to evaporate or leach away before consumption. In many cultures, these preparation methods were developed long before the chemistry was understood, but they're extremely effective. For scientific accuracy, it's important to say that risk can increase under certain conditions. For example, when large quantities of these foods are consumed, when the seeds or kernels are finely crushed before ingestion, and in the case of cassava and sorghum, when these foods are improperly processed. Under these circumstances, the body's detox capacity can be exceeded. Under normal dietary conditions and proper food preparations, these foods are generally safe. Despite the fact that many everyday foods contain compounds that can release cyanide, there are several factors that stand between you and harm. The cyanide is chemically bound. The seeds are often swallowed intact. The amounts consumed are usually small. Your body can detox limited exposure. And to top it all, traditional food processing methods like fermenting removes much of the risk. So, under normal dietary conditions, you are safe. If you enjoyed this deep dive into real world chemistry, then please subscribe to my channel. See you in the next video.